بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we're going to continue talking about numerical sequences, and specifically we will see the arithmetic and the geometric sequences. Now the general term of an arithmetic sequence and a geometric sequence. General term means to write un in terms of n. Well, for all natural numbers n and p, un is an arithmetic sequence. The general term of the arithmetic sequence is given as un is up plus n minus p d, where d is the common difference. N is the index of this term and p is the index of that term. Okay, let's take an example. Un is an arithmetic sequence. We do know that it's arithmetic. We need to find the general term of un, knowing that its common difference is 3 and u0 is 5. Now here try to specify what is the question and what are the given. We are given here that the common difference is 3 and we know u0 which is 5, and we need to find un. So un is a question mark, and we apply the property un is up plus n minus p d. Here specifically, because we know u0, we can replace p by 0. So for p equals 0, we can get here un is u0 plus nd, and u0 is 5, we just replace it, and d is given as 3. So un in this case is 5 plus 3n. Part B, find the common difference of un, knowing that u5 is negative 6 and u11 is negative 18. Now here we know u5, we know u11, and we need the common difference d. So d is the unknown, and we know n and p, and we know two terms. So in this case, if we take n as 11 and p as 5, we get u11 is u5 plus 11 minus 5d. We are just replacing values, and from here you can see that d is negative 2. Okay, now let's go on to geometric sequence. For all natural numbers n and p, un is a geometric sequence, and the general term of a geometric sequence is un, which is up times r to the power n minus p. Un is a geometric sequence. We need to find the general term, knowing that its common ratio is 5 and u2 is 2. You see here we are given u2. Again, we know the common ratio, which is r, that is equal to 5. We know u2 and we need un. Un is up times r to the power n minus p. For p equals 2, we get un is u2 times r to the power n minus 2, which is here 2 times 5 to the power n minus 2. Now we need to find the common ratio of un, knowing two of its terms. We know u3 and we know u6. We go back to the formula of the general term. We need r, and we use the formula for n equals 6 and p equals 3. We can replace, we get u6 is u3 times r to the power 6 minus 3. And in this case, with the sum calculations, we get r equals negative 3. Well, remember, to have an arithmetic sequence, un plus 1 minus un should be a constant. To have a geometric sequence, un plus 1 over un should be a constant. The general term of an arithmetic sequence is un, which is up plus n minus pd, and the general term of a geometric sequence is un equals up times r to the power n minus p. Let's see this application together. The terms below are the terms u1, u2, u3, u4, and so on of an arithmetic sequence. We need to write un in terms of n. Well, these are the 4 values. Try to write un in terms of n. Pause the video and try to work it out. Okay, in this case, d is the difference between any two consecutive terms. So 6 minus 10 is negative 4. We can also use 2 minus 6, which is negative 4, and so on. And we can choose u1, which is 10. We can also choose u2, u3, u4. It doesn't matter. The formula un is u1 plus n minus 1d. Just replace to get un is minus 4n plus 14. Now let's see the second example. I, 3i, 5i, 7i, and so on. Try to do it alone. Try to write un in terms of n. Okay, d in this case is 2i and u3 is 5i. You could also have chosen u1, which is I. un is u3 plus n minus 3d, which is 2in minus I. Now the terms below are the terms of a geometric sequence, and we need also to write un in terms of n. This is the first case. Try to do it alone. Pause the video. Okay, R is the ratio of any two consecutive terms. It's 6 divided by 3, which is 3, and u1 is 2. As I said before, you can choose u1, u2, u3, u4, and so on. un is u1 times r to the power n minus 1, which is 2 times 3 to the power n minus 1. Let's see another example. Try to do it alone. R is radical 2 and u2 is 2. un is u2 times r to the power n minus 2, which is radical 2 to the power n minus 1. Let un be an arithmetic sequence. The sum of its terms, it means u0 plus u1 plus u2 plus blah 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 plus un, is n minus p plus 1 over 2 into up plus un. n minus p plus 1 in this case represents the number of terms. So how many terms do we have from p to n? They are going to be n minus p plus 1. Now let's see this example. We need to find 1 plus 3 plus blah 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 plus 2n minus 1. You begin by specifying that u1 is 1, u2 is 3, u3 is 5, and so on, and un is 2n minus 1. In this case, un is an arithmetic sequence with common difference 2 because we are always adding 2. So we need to find the sum of this arithmetic sequence beginning from 1 and ending at n, applying the formula for p equals 1 and for n equals n. We get n over 2 into 1 plus 2n minus 1, which is n squared. Now let's check up the answer whether it's correct or not. For example, for n equals 3, it means we are adding the first 3 terms. Now what is 1 plus 3 plus 5? It's going to be 9, which is 3 squared. And in this case, the sum is going to be 3 squared. For example, for n equals 4, we are adding the first 4 terms. And this gives 16, which is 4 squared. And here, if we replace n by 4, we get 4 squared, which is 16. Okay, now let's go on talking about the geometric sequence. un is a geometric sequence, while the sum in this case of its terms is going to be up into 1 minus r to the power n minus p plus 1 over 1 minus r. Remember again, n minus p plus 1 is the number of terms of the sequence. Well, let's find this sum. This is the sum of a geometric sequence because we are always multiplying by radical 2. Let's begin. u0 in this case is 1, which is radical 2 to the power 0. u1 is radical 2 to the power 1. u2 is radical 2 to the power 2. And so on till we get un, which is radical 2 to the power n. So un is a geometric sequence with common ratio radical 2. The sum applying the formula would be u0 into 1 minus r to the power n minus 0 plus 1 over 1 minus r. And here we are replacing p by 0 and n by n. After simplification, we get this quantity. Now let's check up the answer. For example, for n equals 0, if we replace n by 0 here, we get 1 minus radical 2 over 1 minus radical 2, which is 1. And the sum of the first term is 1. For example, for n equals 4 means we need u0 plus u1 plus u2 plus u3 plus u4, which is, if we replace n by 4 here, we get this quantity, which is 7 plus 3 radical 2. And if we find u0 plus u1 plus u2 plus u3 plus u4, we get the same quantity. Okay, remember, the list is becoming longer and longer. We've added the sum of an arithmetic sequence and the sum of a geometric sequence. Let's see this application. Find the sum of the numbers from 1 to 100. Try to do it alone, pause the video and work it out. Well, if we want 1 plus 2 plus 3 plus 100, this is an arithmetic sequence where the common difference is 1 because we are always adding a 1. D is 1 and U1 is 1. The sum would be, applying the formula, 50-50. Another application, write this sum in terms of n. Try to do it alone. Well, this is the sum of a geometric sequence because we are always multiplying by 1 over 2. So r is 1 over 2 and u1 is half. Applying the formula, we get 1 minus half to the power n minus 2. Thank you.